So ICMP version 4 messages are classified into two.
دكتور بس للزحمة.
Sorry.
دكتور.
No. Uh, there are two broad categories, the error reporting messages and the query messages. Error reporting messages to report problem that a router or host may encounter when it processes an IP packet. Or query messages. Actually, query messages will normally use them in pairs. We'll see some examples about this. So let's talk about the error reporting messages. IP, as we said, is unreliable protocol. So ICMP actually helps IP to deliver some messages when there are some errors. Error messages are always sent to the original source. So you want to connect to some destination and there is an error that happens during the path from source to destination. The error message, ICMP error messages, are always sent to the original source because no one else is concerned about the error maybe, and there is no other information. It's only the source address and destination address, so you can only forward it to the source address, the error. ICMP uses the source IP address to send the error message to the source of the data graph. To make the error reporting process simple, ICMP follows these rules in reporting messages, error reporting messages. No error message will be generated for a datagram having a multicast address, okay, or special address, such as loopback address, because this one will not even leave the device, so you don't need to generate error messages. Or if it's a multicast address, the destination is a multicast address, the error message will not be generated in this case, because if it's a multicast, then it's not reasonable that all of them, if there are problems, report you the error. No ICMP error message will be generated in response to a datagram carrying an ICMP error message. So if you received an ICMP error message and you'll not generate an ICMP error message for that message. No ICMP error message will be generated for fragmented data if that data is not the first fragment. So when you fragment data, you have first, second, third, and so on fragments of the data. So if ICMP will only generate the ICMP error message for the first fragment only, not the other ones. We may explain why later. Destination, so the error messages, for example, destination unreachable. You've seen this error message. This error message is widely used, and this message uses different codes from 0 to 15 to define the type of error message and the reason why the datagram has not reached its final destination. For example, code 0 tells the source that the host is unreachable. This may happen, for example, when you open a website, you use the HTTP protocol to access the web page, but the web server is down. You receive errors on the, for example, on your browser, destination unreachable, and there is some error code. So this is generated by actually ICMP. The message destination host is not reachable is created and sent back to the source. So if you are using a browser, your browser may tell you that destination host is not reachable and some error code. That's also this is generated by ICMP. Source quench is a message informs the sender that the network has encountered congestion. So if the destination, for example, there is one router from source to the destination, there is loss of load on that router, so it may respond with a source quench message to the sender, so that the sender will know that there is a congestion, loss of traffic on that router. Maybe it will try to resend or delay its data to some time later. Redirection message or type 5 is used when the source uses a wrong router to send its message out. So when you want to communicate with a device on the internet and your route to the internet, your output route, the router default gateway, for example, is wrong, the router redirects the message to the appropriate destination or router, but informs the source that it needs to change its default router in the future, so that your IP or your datagram is forwarded, but you also receive an ICMP error message says it's about redirection of the message. It will tell you that you need to change your router or output route. You've seen this error message in browsers. We'll see also this message, time exceeded message. So if you send a datagram and TTL becomes 0 because it traveled through several routers and TTL reached 0, the datagram is dropped by the visiting router and time exceeded message, which is type 11, is sent to the source, so that you know that this datagram didn't arrive at its destination because time exceeded TTL is set to 0 and it didn't arrive to its destination. Parameter problem message is a parameter problem message type 12 can be sent when either there is a problem in the header of the datagram, code 0 in this case, or some options are missing or cannot be interpreted, so it's code 1 in this case. ICMP query messages are used, can be used independently without relation to the IP, to an IP datagram. Of course, a query message needs to be encapsulated in a datagram because you are not going to send it alone as a carrier. Query messages are used to probe or test liveliness of hosts or routers in the internet, find the one-way or the round-trip time for an IP datagram between two devices, or even find out whether the clocks in two devices are synchronized. Naturally, query messages come in pairs, request and reply. And the example you used is ping. So ping is using query messages. The echo request, type 8, and echo reply. So ping is using these messages. Pair messages are used by host or a router to test the liveliness of another host or router. A host or router sends an echo request message to another host or router. If the later is alive, it responds with an echo reply message. Example application is ping and trace route. So ping and trace route both use these type of messages. The timestamp request also is used. Pair of messages are used to find round trip time between two devices, and you can check if their time is synchronized. We have several debugging tools. You use ping. So ping is using, as we said, the ICMP echo request messages. Okay, so it's using the echo request messages. The source host sends ICMP echo request. Okay, and the destination, if it's alive, replies with echo reply message. The ping program sets the identifier field in the echo request and echo reply message and starts the sequence number from 0. This number is incremented by 1 each time a new message is sent. So if you check the header here, you have the you set the identifier or sequence number here to say 0, 1 and so on. So because these are in pairs, so when the echo sequence number 0 arrives at destination, it replies with echo reply with sequence number 0, and then you send echo sequence number 1, the destination will reply with echo with sequence number reply 1, and so on. Ping can calculate the round trip time, RTT, round trip time. It's easy. It inserts the sending time in the data section of the message. So here you have data section of the query message, because we said ping uses the echo query message. It has this header, this structure. So in the data section, it inserts the time. Okay. When the packet arrives, it subtracts the arrival time from the departure time to get the round trip time. So you send, in the packet you insert the current time, you send it, and you receive it. You have the time now. You subtract this from this one, and you get the time, round trip time. Round trip means to the destination, from the destination to the source. That's round trip time. We have also trace route. This very important debugging tool. Trace route is an application layer program. So it's a program, but it uses what? It uses ICMP messages to check the route from the source to the destination. The program is usually set by default to check the maximum of 30 hops or routers. So hop means a router to be visited. The number of hops in the internet is normally less than this number. So you'll rarely need more than 30 routers or hops to reach to the destination. Therefore, by default, it uses maximum 30. The traceroute program is different from ping program. It's not the same thing. Okay, traceroute program gets help from two error reporting messages: time exceeded and destination unreachable. We see how we use these two types of messages to find the road to the destination. Only the client program is not needed. So you don't need in the destination some traceroute program to run on the destination. You only need the traceroute program application in the client or the source. The client program will never reach the application layer. Okay, when you send the message, it will never reach the application layer in the destination. So you don't need the program in the destination. The traceroute application program is encapsulated in a UDP user datagram, but traceroute intentionally uses a port number that is not available. We'll see in the example later why. If there are n rows in the path, the traceroute program sends n plus 1 messages. The first n messages are discarded by the routers, and the last message is discarded because the destination port is not available. So all the messages will be discarded, and every time an error reporting message is delivered to the source. So let's see the example, traceroute. For example, here you want to do the traceroute from here to here. Okay, what you do is you send a message, first message, to the destination. Okay, so this is the source IP, this is destination IP. You send it with a TTL equal 1. You arrive at this router. Now this will make TTL is 1, will make it minus 1 minus 1, which equals 0. So because TTL is now 0, it should discard the message. So it will discard it, but reply with ICMP error message, time exceeded. So the destination will know the source will know the IP address of this router, the name and IP address of this router. So first, with this first ICMP message with TTL equal 1, you know the IP address of this router. Now you'll send another ICMP message with TTL equal 2. You'll send it from this source to the destination. It will travel, of course, because this was the first router. We'll go through this one. Now, this will make TTL equal 1. It will arrive here. TTL will be 0 again. So this router will also discard the message. Will discard the message and send an error message, destination time exceeded, so that source will know the IP address of this router also. Now you use increment the TTL to make it 3. Now if you use 3, here it will be incremented to 2. Here it will be decremented, to 1, and here is 0. So now this message will be discarded, and you reply with ICMP error message. So the sender will know the IP address of this router also. Okay. Now at the last message, you send with TTL equal 4. In this case, TTL equal 4. So here is 4. Here it will be decremented by 1, 2, 1. This router will not discard it. Okay. So it will go here. But here, we used a port, we used a UDP. We used a port number that's not available here, okay? So again, you'll get a error message because the destination port is not reachable. So you'll get another ICMP error message, and you know the details of the final destination. So you found the route from source to the destination, and the IP addresses of the routers or their names, for example, and using ICMP error query messages. Query actually and error message. So first they were query messages, then error message, destination unreachable, and then the other ones were time exceeded. So you have a echo request, but because the TTL will be 0, it will be reply that you'll get a reply with a time exceeded message. On the final one, you'll get the destination unreachable error. So this is the explanation of this figure. In Windows, we don't have this program. This is in Linux or Unix, trace route. In Windows, we have trace RT. You can use it. It's somehow similar to trace route. The trace RT program in Windows behaves differently. The trace RT messages are encapsulated in IP datagrams. You see, the other ones were not. Trace RT, like trace route, sends echo request messages, again with variable TTL. TTL start from 1 up to the maximum you want to. When the last echo request reaches the destination host, an echo reply message is issued. Okay, so this is also different. In the other one, when you reach the destination, you get this destination unreachable because you use a port number that's not available here. So you get different error message. So both of them will give you the road to the destination, but this one behaves differently. You can try both of them and see how they report the road from source to destination. I think we used, we can start if you'd like. I'll start just one example and see. So you can do it yourself. For example, if you trace RT, trace you see these are the options for trace RT. So if for example say trace RT google.com, you see you'll send messages. So this is the first router. I know. Now I send another message with another TTL. You get the IP of the next, and so on. You see, each router will give you it. You know its IP address and the time it replied until you go to your final destination. You see this request timeout message, not normally we not only send one message, but we'll send 3 messages so that we can take the average times, so that we can calculate these times more accurately. You see over a maximum of 30 hops. But you can't change the maximum number. By default it's 30. You can change it. For example, make it 10 or 40. until you get to the destination. This is a trace RT, not trace route. So they are slightly different how they work.